Hi, this is Maggie. In this video we're going to talk about creating a background from a map and set of tiles. Generating terrain from tiles saves memory and allows you to generate an unlimited set of background options from a small set of images by creating or editing a text file. This is useful for generating large worlds and levels, for example. Figure 9.18 from your book illustrates how terrain is generated from a set of tiles. In Figure 9.18, there are 3 tiles: green, blue, and brown. In real games, the tiles are more interesting, of course, but you can get the idea from this simple example. The tiles are small images that we load into pygame surface objects and store in a list. The tiles are numbered, corresponding to the indices they have when loaded into the list. The terrain is a text file of indices. In this image, the first row of the text file is all ones, corresponding to the blue tile, because that tile is at index 1 in the list of tiles. The second and third rows are also ones. The fourth row is zeros, corresponding to the green tile, and the final row is 2, corresponding to the brown tile. A row can be a mix of numbers, of course. This image is very simple and could be interpreted as dirt, grass, and 3 rows of sky. You can see the map rendered over here on the right. When constructing the background, we generate a surface that has a width, which is the tile width multiplied by the number of tile indices in a row, and a height, which is tile height multiplied by the number of rows in the terrain file. We then loop through the indices and blit the appropriate tile surface to the appropriate location in the background image. This can easily be accomplished with a nested loop. In the inner loop, we draw a row, and in the outer loop, we iterate over all of the rows. So to start, we would set row at 0 and column at 0, and then in the inner loop we iterate by incrementing column, splitting the tiles list sub-row, sub-column to column times tile width, row times tile height. Increment column to 1, split to column times tile width, row times tile height. Increment column to 2, split to column times tile width, row times tile height, etc. Then we increment row to 1 and set column back to 0 and repeat the inner loop. If this is a little confusing, then I suggest you map out the coordinates of these tiles. Assume they have a width and height of 50 pixels, for example, and write both the row and column indices and the x and y coordinates, and find the relationships and patterns that allow us to implement this as a loop. Start by writing the inner loop, the loop that would blit a single row. We will modify the template program to generate a tiled background. I've renamed the template to tiledbackground.py. I've created some very simple tiles and placed them in a folder called tiles, and I've numbered them with the numbers of their indices. This relates them to the terrain.txt file that I created in a text editor. Here is the terrain.txt file. So the zeros in the text file should be filled with 0 _tile.jpg and the ones with 1_tile.jpg, etc. What this looks like is a really simple and basically unplayable board game. But the beauty of this is if I create different tiles and a different terrain, my program will generate a completely different background. Generating a background from terrain is a process that we can write in a very abstract way, allowing us to get an infinite variety of specific results. So it can look as good as I can make it, which, with me as an artist, is not very good. There are tile sets available for you to use free of charge on the internet or for a price. I found some using a Google search. If you use somebody else's art, confirm the license before distributing the work publicly. Okay, so in the text, there's a function called makeBackground that basically does all of the work for us. So we will not be using that. Let's figure out what we need to do. We need to load the terrain.txt file into a data structure, such as a two-dimensional list. We need to load our tile images into a list of surface objects and find the width and height of the tiles. We can then create the screen and create the background surface objects, and then build our background by iterating over our terrain map data structure and blitting our tile surface objects to the background. So I'm going to first put comments in describing all of that work that we're going to do, and I'm going to change make window to take a width and a height as parameters rather than just size, because the width and height might be different and are determined by the terrain in the file in this program. And I'm going to pause the video while I do that because it's really not related to creating the background from the tiles. Okay. Most of the work we're going to do is in the Setup Assets area of the template, except for annotating some new variables and changing the make window function. Because this isn't a game, just a demonstration of creating a surface from tiles, the game loop, which does nothing but blit the background and flip the display, is fine as it is. Now, one easy piece of this that we can knock off before we tackle the things that are new is to create the list of tiles, which simply involves loading in 5 JPEGs to a list of surface objects. I want to note that I can't convert them until I set the video mode when I create the screen. So I will load but not convert. I would have to convert them after creating the window. So I'm also going to write a loop at the end of all of the comments, converting those surface objects. Okay, now let's think about the first step here. Load the terrain text file. When you're loading data from a file, you need to think carefully about what the file looks like, and ideally you're very careful about error checking. So, for example, we would consider that the file might not exist, that the file might be empty, that a line might be incomplete, etc. Here I'm going to assume a correct file, but you might enhance what we write here to check for error conditions, like the ones I've described. Now I'm going to go to the console and open the file and read a line, and let's see what that looks like. This is what I mean about understanding what the file looks like. We know from creating the file that it's got rows of numbers separated by spaces. Okay, so I'm going to open the file. File equals open terrain.txt. And then I'm going to read a line and we'll look at it. Line equals file.readline. And then we'll ask the interpreter to evaluate line. And it's a string, exactly what we saw in the file with a new line at the end. What happens if we split the line? Remember that split will create a list of the elements in the string using whatever delimiter we pass to the split method. The default delimiter is whitespace. So if I write split line equals line.split, and we ask the interpreter to evaluate split line, we see a list of strings. Now you may not have expected that. Remember that we're going to use these to index into our list of tiles. So it's important to recognize that if we create a terrain map by iterating through the file, reading the lines, splitting them, and appending them to a list, that we are appending a list of strings, not integers. So let's write code to create that structure. I'll create an empty list called terrain. And then I'm going to use the with construct to open the terrain.txt file as terrain file. And then I'll loop through the file and read each line, split it, and append it into the list. So line equals terrainfile.readline, while line does not equal the end of file character, terrain.append line.split. Line equals terrainfile.readline. Again, I'm assuming there's a file and it has at least one line of terrain in it. Okay, now that I know the number of rows and columns in the map, and I have my tile images loaded into surface objects, I can calculate the size of the whole window. I'll create variables for the tile width and tile height. And get the width and height of the 0th tile in the tiles list to set those. Now the width of the overall window is going to be the number of columns in the map, which is the number of elements in one of the lists within the list terrain. So I'll take len terrain sub 0 multiplied by the width of the tiles. And the height is the total number of rows in the list terrain, which is len terrain, multiplied by tile height. Now I can create the screen and the background using those values for width and height. Now we have one step left which is using the terrain map to blit the correct tiles to the correct location within the window. This is going to be the nested loop. Let's do the inner loop first, which is the loop in which we'll iterate over a single row and blit the images to the correct XY location. I'll initialize X and Y variables to 0. Now assume we're given a row. Remember that a row is a list of strings where the strings are string versions of our indices into the list of tiles. So a string representation of 0, 1, 2, 3, or 4. We'll use those to index into our list of tiles to get the surface to blit. And then we'll increment the X coordinate to move to the next location for the next tile. So for I in row, background.blit, and then we index in, but we must convert that string to an integer. So tiles sub int I, and then x, y. And then we need to move x along by the width of the tile. So if our tiles are 50 pixels and it started at 0, for the next blit it will be 50, and then 100 and 150, etc. So x plus equals tile width. That's our inner loop. Once we've completed a row, we want to reset x back to 0 so that we go back to the left side of the screen. And we want to increment y by the height of the tile so that outer loop will put it around our inner loop. Looks like for row in terrain, and now for I in the row loop, and then when that's finished, looping through all of the indices in the row, y plus equals tile height, x equals 0. Now, let's run that. And you can see that it draws a picture, and it does correspond to our map. And just to illustrate how flexible this is, let me modify the map some. You see this big black space in the middle? In the map, that's all of these zeros. Let me put some other colors in there. So I'll put in some colored tiles, say index 2. And I run the program again. And there's a row of blue tiles there. So it's not at all difficult to modify the map. Let me do one more modification. Let me change the size of the window. I'll just chop off a whole bunch of rows. And we run again. And now we have a smaller window. Let me put everything back. One more change. I have this soft blue tile, and I'll rename the black tile to have an underscore in front of the name. and I'll name the soft blue tile 0tile.jpg. And we'll run again. And now the background is that soft blue instead of black. So the program creates the background entirely from what is in the files. And you could, of course, create a file with more information to make it even more abstract. You could create a settings file that includes the names of the tile images to be used, the number of tile images, whatever information you want. Okay, so this is maybe tricky because it involves files, nested loops, and multiple related data structures, but if you practice with it and make sure you really understand how it works, then you can recreate it yourself. Make that a goal, to create a tiled terrain reader from scratch. Once you can do that, you're ready to move on.